Good day, everyone. I'm from session 8 and group 16. I'm Cui Tianxun.
Hi, I'm Song Ruiyao. The first one is introduction and problems. Drug abuse has become a major global public health concern. In recent years, the number of drug-related deaths has increased significantly across many countries. One important issue is that many of these dyes involve multiple substances rather than a single drug. This makes a analysis more complex because the interaction between drugs can significantly increase risk. There are several key problems in the study. First, although the number of deaths is increasing, the trend is not fully understood. Result per Reaper analysis, it is different to identify patterns or predict future risk. Second, the relationship between demographic factors such as age, sex, and race with drug-related deaths is unclear. Understanding the relationship is important for identifying high-risk groups. Third, multiple drug usage is common, but the interaction between different drugs is not well studied. Some combinations may be far more dangerous than others. Finally, there are rare or unusual cases in the dataset. These cases are difficult to detect using traditional methods but may provide important insight into high-risk situations. Therefore, their determining techniques are needed to analyze their complex patterns in a structured and effective way. The next is objective and dataset. To address the problems mentioned earlier, were defined several objectives. First, to analyze trends is drug-related deaths to understand the general patterns. Second, to identify high-risk demographic group based on variables such as age, sex, and race. Third, to study the relationship between different drugs, especially combinations of substances. Finally, to detect anomalies for unusual cases that may represent rare but important patterns. Now let's look at the dataset used in this project. The dataset contains 11,981 records and 48 attributes. Each record represents an individual drug-related death case. The detailed deaths include different types of variables. There are numerical variables such as age, which can be used to analyze trends. There are also characteristical variables such as race and race, which help us understand demographic patterns. In addition, the dataset include multiple drug-related variables such as heroin, cocaine, fentanyl, benzodiazepine and methadone. This makes the dataset suitable for applying various determining techniques. However, one challenge is that the dataset contains missing value, especially in drug-related columns. Therefore, proper pre-processing is required before applying any model. The next is data preprocessing. Data preprocessing is a critical step in any data mining project. Raw data often contains missing value, inconsistent formats, and irrelevant information. If not handled properly, this issue can negatively affect model performance. First, we handle missing value. For the each variable missing value, we're often using the mean value. This helps preserve the overall distribution of the data for category for for categorical variables such as sex and race missing value and were replaced with unknown. This ensures that no data is lost worth allowing the model to process the information. Next, we transform drug-related columns into binary format. A value of 1 indicates the presence of a drug, while 0 indicates its absence. This step simplifies the data set and makes it easier for machine learning model to process the data. After that, we apported one hot encoding to categorical variables. This converts categories into numerical format without introducing any false order between them. Finally, we selected only the most relevant features to reduce complexity. Overall, these pre-processing styles improve data quality, reduce noise, and enhance model performance. The next is classification. For classification, we used logistic regression because it is simple, fast, and easy to understand. This is important because we want to see how different factors affect drug-related deaths. We split the detail into training and testing sets using an IT 80-hour and 20 minutes ratio. The model got an accuracy for about 78 more 99%, which means it can correctly classify most cases. We also looked at feature importance using the model coefficients. Fentanyl has the biggest effect, where methadone and some race-related factors also have strong effect. This shows that some drugs are closely linked to opioid related dice and are key risk factors. The last one is evaluation. To evaluate the model, we used accuracy, percent recall, and F1 score. Precision show how many predictably positive cases are correct, while recall show how many real positive cases are found. We also use the five-fold cross-validation. The average accuracy is about 80%, 80%, which means the model work well on different part of the data. This shows the model is stable and work well on new data. Now I will pass to my teammate to continue the presentation.
Okay, so now let's move on to clustering. In this project, we use k-means clustering to group similar cases together. We selected k-means because it is simple, efficient, and widely used in data analysis. It's especially suitable when we want to explore the patterns in data without predefined labels. This basic idea of k-means is to divided the data into the groups based on the similarity. Data points that are close to each other will be placed in the same cluster. The model works by updating cluster centers until the grouping becomes stable. In our case, we set the number of the clusters to 3. We choose this value carefully. If the number of the clusters is too small, we may miss important patterns, and if it's too large, the result becomes too complex and difficult to interpret. So choosing 3 clusters allow us to balance simplicity and meaningful segmentation. After applying the model, the dataset was divided into the 3 clusters. The number of the case in each cluster is class 1 have 4,195 cases, class 2 has 3,950 cases, and the cluster 0 have 3,800 36 cases. We can see that distribution is quite balanced. This is an important observation. It means that the data is not dominated by a single pattern, but instead contains multiple distinct groups. Now let's think about what this cluster represents. Each cluster must correspond to different type of drug-related cases. For example, one cluster may represent cases involving strong uh, opioids such as the fentanyl. Another cluster may include cases where the multiple drugs are used together, and the third cluster may reflect the difference in the demographic factors such as the age or the race. Even though clustering does not give exactly labels, it helps us understand the structure of the data. It's very useful in real-world problems where patterns are often hidden. Clustering allows us to discover these hidden patterns without making assum- assumptions. Another important point is that clustering complements the classification. Classification help us predict the outcomes, while clustering help us understand how the data is grouped. Together they prove a more complete analysis. Okay, so next, we applied anomaly detection to identify error cases in datasheet. We use the isolation forest algorithm. We choose this method because it's efficient and works well with high dimensional data. It's not designed significant to detect rare or abnormal cases. The idea behind the isolation forest is quite intuitive. Normal data points are similar to each other, so they are hard to isolate. However, anomalies are very different from the rest of the data, so they can be isolated more quickly. In our model, we set a contamination level to 5%. This means we assume about 5% of the data are anomalies. After running the model, we detect the 599 anomalies. This is very close to 5% of the total dataset, which shows that the model is working at expected. Now let's understand what these anomalies represent. These are cases that are very different from the majority. For example, there include cases with race, combination of drug cases involving very strong or dangerous substances, cases are with unusual demographic profiles, and these cases are important because they may represent high-risk situations. Even though they are very small in the number, they can provide very valuable insights. For example, a case involving multiple strong drugs have much higher risk of death. By identifying the anomalies, we can focus more attention on these critical cases. This is very useful in real-world applications. For example, healthcare professional can use this information to identify the high-risk patients. But policy makers can also use this to design the target prevention strategies. Therefore, anomaly detection is not just a technical step, but also has important uh, particular implications. Okay, and here is the visualization and the insights. To better understand our findings, we use the data visualization techniques. In this project, we created a calculation heat map. A heat map is a visual tool that shows the relationship between the variables using colors. Stronger relationships are shown using more intense color. This makes it easier to identify the parties at a glance. From the heat map, we observe strong relationship between the fentanyl uh, methadone and apply the related cases. This suggests that these drugs are highly associated with drug-related deaths. Let's discuss the key insight in more detail. The first, some drugs are more dangerous than others. For example, fentanyl shows the strongest influence in our model. This consistent with real-world knowledge as fentanyl is known to be a very powerful opioid. The second drug combination significantly increase the risk. This means that using the multiple drugs together is more dangerous than using a single drug. This is a very important finding because many real-world cases involve the multiple substances. The third, demographic factors also play a role in the patterns we observe. For example, different groups may have different exposure to certain drugs. This suggests that both drug-related and demographic factors need to be considered together. Visualization is important because it helps us understand the complex data more easily. Instead of looking at the numbers, we are directly see the parties and the relationship. This makes it easier to communicate our findings to the others. Okay, in conclusion, this project demonstrates the effectiveness of data mining techniques in the analyzing drug-related death data. This classification model and logic regression and achieve the good predictive performance. It also helps us understand which factors are more important. Clustering allows us to group similar cases and identify the hidden patterns. A normal detection help us identify the rare and high-risk cases. Together, this method provides a comprehensive understanding of the dataset. However, there are many limitations. Our limitation is the presence of the missing data. Although we handle it missing values, this may still affect the accuracy of the model. Another limitation is that the dataset may not include all relevant variables. For example, factors such as location or income level are not included. In the future, we can improve this project in several ways. First, we can use more advanced models such as the random forest or the deep learning. Second, we can include more the features to improve the analysis. The third one, we can use larger and more recent datasets. Overall, this project highlights the importance of the data-driven approaches in the understanding the complex public health issues.